I am from RAS 1202G. My metric number is 2019222786. Thank you.
Hi, Assalamualaikum guys. My name is Shaizati binti Amran from group RAS 1202G. Metric number 2019286278.
Hi, my name is Syafiqah binti Rizwan, 2019227884, and I am from RAS 1202G.
In an engine, an almost ideal gas is compressed adiabatically to halve its volume. In doing so, 1,350 joules of work is done on the gas. The question is, how much heat flows into or out of the gas? So, the answer is the Q is equal to 0 because in adiabatic process, no energy enters or leaves of the system. The second question is, what is the change in internal energy of the gas? So the answer is, we should list out all the information from the question given. We get Q equal to 0 and W equal to negative 1350 joules because in the question say the work is done. That means the work is negative. So we can find the internal energy by using the formula delta U equal to Q minus W, which is 0 minus negative 1350. So we get delta U equal to positive 1350 joules.
The question given for us, 1,500 joule of heat was added to a gas. The gas expanded at a constant pressure of 45,000 Pascal from 0.02 meter cube to 0.05 meter cube. So for A part, how much work was performed by the guest or on the guest? Okay, first of all, we need to list out all the information given for us. So now we have Q at 1500 joule, and then the change in volume, we have 0.05 minus 0.02. For the change in volume, we need to calculate it as V final minus V initial. So we get positive 0.03. And we have the pressure at 45,000 Pascal. And what is the work was performed by the guest or on the guest? Okay, so to calculate the work, we have if we have the pressure constant, we can use the formula W equals to P delta V. So just substitute all the information given, and we need to find work. Just substitute pressure with 45,000 times by the change in volume with 0.03, then we get positive 1350 joule, which is positive value whenever the work is positive, so it is work performed by the guest. Okay, for B part question, calculate the change in internal energy of the system. So we know that 1500 joule heat was added to the system. Therefore, Q is positive 1500 joule. For part B, use the same formula as before, which is delta U is equal to Q minus W. Just substitute the information given for us. We have already calculated for the W, which is positive 1350 joule just now, and then just substitute in this formula, and then we get 1500 minus 1350, and then we get 150 joule. It is a positive value. So when we get positive value, so the internal energy increases by 150 joule. This is delta U.
Okay guys, in this question, I will focus on the second law thermodynamics. We will solve the problem associated with heat engines. So, heat engines, by conservation of energy, we will use the formula QH equal to work plus QL. So, if we want to find the work, the formula is QH minus QL. Okay guys, the question is, a gasoline engine takes in 12,000 joule of heat energy per cycle and produces 2,400 joule of mechanical work. A, how much heat energy is removed per cycle? B, what is the efficiency? C, what mass of fuel is consumed in each cycle if the heat of combustion is 45,000 joule per gram? Okay, we continue in the question with the diagram that I draw. So, 2000 joule is the QH because it entered the system. This is the work. Mechanical leave the system, 2400, and we will find the QL. So, how to find the QL? So this is the formula that I told before. So QH is 12,000 minus with work, it is 2,400. So we will get the 900
9,600 joule. This is for part A. So, for part B, what is the efficiency? So, the formula to find the efficiency is efficiency equal to work divided by QH times 100%. So, we know the work is 2,000 at 400 divided by QH, it is 12,000 times with 100%. So, we will get the 20%. For the next question is C. What mass of fuel is consumed in each cycle if the heat of combustion is 45,000 gram per joule per gram? So, heat of combustion is 45,000 joule per gram. We will need to use QH because the energy absorbed by the system comes directly from the gasoline. Let's start with 12,000 joule convert into grams. This is the number that 1 gram of gasoline it releases 45,000 joules, and you want to write it in such a way that the unit joules cancel. So we cancel the joules unit. So you get the grams. It is 0.2667 gram.
Okay, hi. For question 4, we will answer about the efficiency of heat engine question. In this subtopic, we have two equation formula to be remembered, which is the first one is efficiency equal to work over QH, and the second equation formula is efficiency equal to 1 minus QL over QH. Okay, we have two parts, which is A and B. Part A, what is the efficiency of a cyclical heat engine in which 75.0 kJ of heat transfer occurs to the environment for every 95.0 kJ of heat transfer into the engine? So, in part A, we are given QL and QH. QL is equal to 75.0 kJ and QH is equal to 95.0 kJ. So in this case, we need to use the second equation formula, which is efficiency equal to 1 minus QL over QH, because we are given QL and QH. Okay, part B. How much does work it produce for 100 kJ of heat transfer into the engine? So, for part B, we are given QH and QL not given. We are asked for work. So, QH is 100 kJ, and we need to use the first equation formula, which is efficiency equal to work over QH. Okay, in part E, we need to use the second equation formula, which is efficiency is equal to 1 minus QL over QH. So just substitute 1 minus 75.0 in this case and 95.0 in this case. So we will get 0.211. So if we want to convert it into percent, just times by 100 and we will get 21.1% efficiency. Next, for part B, we need to use the first equation formula, which is efficiency is equal to work over QH. So now QH is given and we know the efficiency and we have to find work. So rearrange and make work the subject. So work is equal to is going to be efficiency multiplied by QH. So E times QH. So just substitute 0.211 times QH given is 100 kilojoule. So we will get 0.211 times 100, 21.1 kilojoule, as it is a work.